Now we're going to take a look at using the FlowTrax IV pump analyzer with a couple of B-Braun IV pump products, one older, one newer technology from a company called B-Braun. The lower pump here is a B-Braun Outlook 100, and the upper pump here is the B-Braun Infusion, otherwise known as the Space pump. We're going to run a volume test on each at the manufacturer's recommended flow rates with using the FlowTrax. I've already flushed both IV sets of any unwanted air, so I've got solid water in the IV sets. I've got the B-Braun Outlook IV pump connected to the FlowTrax right now, and the FlowTrax is primed and zeroed. We've got the output of the FlowTrax going into a graduated cylinder sitting on top of a digital scale. Both are commonly or used sometimes for measuring volume of IV pumps on the market today. So we'll look at the measurements on the FlowTrax and compare those to the graduated cylinder and the digital scale at the end of the test. I've programmed the B-Braun Outlook 100 for 120 milliliters per hour, which is what the manufacturer recommends for a rate for doing the volume test. The manufacturer calls out for a 10 milliliter volume, but in the case of FlowTrax, I only need 6 milliliters of volume to hit the device's 1% accuracy spec. So I can actually cut the time that it takes to test this pump almost in half if I choose to use the FlowTrax in my measurement. Let's go ahead and start the pump after making one quick change on the FlowTrax. I'm going to select a different rate measurement. So I go into Setup, More, Readings, Rate Mode. I'm going to use Volume over Time. That is the best rate measurement technique for this particular IV pump, given the flow pattern that it has. I've made that selection on the FlowTrax, and it actually shows V over T in the lower corner there, telling me that that's the measurement technique I'm using for the flow rate average. I can start the pump now, and it's going to start moving fluid through the FlowTrax. We can see the digital timer at the bottom of the FlowTrax has started counting the elapsed time. We've got at the top of the FlowTrax display a flow rate average has begun. Below that we've got the cumulative volume that the FlowTrax is seeing. This pump actually puts out roughly 800 microliters for each time it pushes fluid. And you can see right now it's actually pausing, but it will push another 800 microliters or so right now, and it's going to continue to do that. It's going to push 800 microliters, pause for a period of time, and then push again, which is why we wanted to use the volume over time, or V over T, rate algorithm for this pump because of the flow pattern. We've got next line down on the FlowTrax display, the pressure and the max pressure seen during this test. And then, of course, as we discussed, the digital timer is counting the elapsed time of the test. The flow rate average is running kind of close to 120 milliliters per hour. And you'll see when the pump pauses and then starts again, that number will come down a bit as the FlowTrax is calculating the pushes and pauses of the pump throughout this test. Right now we're running the FlowTrax on 2 AA batteries rather than running it off of DC or AC power, and you can see the battery symbol down here in the corner as well. So we're going to run both pumps. I'm going to let this test finish. We're about halfway through it. We'll run both pumps, and we'll take a look at how the flow rate average and the volume turn out on both tests. In both cases, the manufacturer specifies an accuracy of 5% for volume. They do not specify an accuracy for flow rate. So we're up to 4 milliliters now in the cumulative volume. The flow rate average is at 119. It's pushing again. And the total time for this test is roughly 3 minutes. It's a little bit more than that, I think, with this pump. This older B-Braun pump actually has a piston and a cassette that it uses to deliver the fluid, whereas the newer pump that we see on top here uses a peristaltic finger mechanism rather than a piston. So you can kind of see the difference between the two pumps as they run through their volume and flow test. So we're almost at 3 minutes on this test, and the volume during this push is going to end up right about 5.6 milliliters. We should only have about one more push, and it should be finished. And it's going to tell us when it's done by giving us an audible alarm. So that was a 6 milliliter volume test. You can see that the FlowTrax is reporting 5.913. At 5%, the spec would be, at the low end, the minimum would be 5.7 milliliters, and at the high end, 6.3. So that passed its 5% test. If we look over here at the scale and graduated cylinder, I've got to do something with this last big drop that didn't come out. That's just the nature of the beast when you're dealing with collection containers like that. The scale is reading 5.85, very close to 5.915. The graduated cylinder, it's hard to tell. You don't really have a lot of resolution with a graduated cylinder, but it looks like it's around 6, best I can tell. So all three of those devices seem to be agreeing with each other. Now that we've done that test with the older B-Braun, let's go ahead and jump over to the newer B-Braun IV pump and look at some of the differences there. All I've got to do to test another pump is disconnect, in this case, because they're two different IV sets, I'll disconnect the IV set from the first pump. Connect up the IV set for the next pump I want to test to the input of the FlowTrax. Once I've done that, I'm going to turn on the IV pump. Let's go ahead and turn off this other pump so it doesn't alarm at us. And I've already got this newer B-Braun pump programmed for the rate and volume that the manufacturer recommends. In this case, for this pump, they recommend 250 milliliters per hour with a 25 milliliter volume. With the FlowTrax, I can actually do a lesser volume, which will be a faster test, so I can program it for 10 milliliters instead of 25, which allows me to test this pump in less than half the time of the 25 milliliters. So I've got that programmed for 250 milliliters per hour and a 10 milliliter volume. I'm going to hit reset flow on the FlowTrax so that I can zero all my numbers. I don't need V over T for this pump, so I'm going to go into setup, more, readings, and switch it back to the default, which is smart rate. So I've done that. Everything's ready to go. I'm going to zero the scale, and we know that we left off on the graduated cylinder around 6 milliliters, so we can keep track of that. I'm ready to start the pump. I've started the pump. We're running at 250 milliliters per hour. The FlowTrax has started averaging the flow rate. It started calculating the accumulative volume. You can see here that we're not seeing those long pauses any longer with this pump. And the flow rate average is already coming very close to what the programmed flow rate is. Again, we've got a digital timer running that detected when the flow started, and it's going to continue to tell us what the elapsed time is of this test. So in this case, with 250 milliliters per hour and a 10 milliliter volume, it's going to be a little bit less than 3 minutes. But you can see that the volume is continually climbing with the newer B-Braun pump, whereas with the older B-Braun pump, you could see that there were significant pauses occurring throughout the test. The spec again on this is similar to the older pump. It's a 5% tolerance, and at 10 milliliters of volume, that means we should see somewhere between 9.5 milliliters to 10.5 milliliters when the test is completed. Our flow rate average right now is well within specification. If we look at that average of 247.4, that's about 2.5 milliliters. That's almost 1% agreement with what the IV pump was programmed for. We're up to a little over 7 milliliters of volume, so we're about 3/4 of the way through the test. We can still see the pressure and the peak pressure that's occurring during the test, which is real helpful when you go to do an occlusion test, of course. And we're right about 2 minutes. So we've got probably about 30 seconds left. We're already at 9 milliliters of volume, 1 milliliter to go. And we'll be finished with this pump. So should be ending here really quickly. We've got 9.9. The pump told us it's finished. I hit the stop button. My flow rate average was 250.5 on the flow tracks. That's extremely close to the programmed rate of 250. My volume reads 10.035. Let's take a look at the digital scale. It's a little lower than that, but we know that these digital scales can have a bit of drift, but we're seeing about 9.61 on that digital scale. The graduated cylinder is reporting, let's see, so that looks like it's right about 10, and maybe a little bit over 10 milliliters. So that completes the test of this IV pump. We can see that it is passing its 5% spec very nicely, and it took only about 2.5 minutes to get there. So now that we're done with a volume accuracy test on the B-Braun Infusion Space IV pump, we're going to do a quick occlusion test. They actually call for testing the occlusion pressure at multiple levels on this pump. We're just going to choose 2 of those levels or stages and do a quick test. Right now, the B-Braun Space is set for level 1 or stage 1 in terms of what occlusion pressure it will alarm at. The manufacturer calls for a rate of 250 milliliters per hour doing occlusion testing, so I'm going to start that at 250. To get an occlusion alarm to happen on the IV pump using the flow tracks, I'm just going to turn this occlusion knob, and I can watch the pressure rise on the flow tracks. The occlusion pressure that the IV pump started alarming at was a max pressure of 8.34, and the tolerance on this level for this pump is anywhere from 1.45 to 8.70, so this pump is passing based on its specification and test procedure. Let's go ahead and remove that occlusion on the flow tracks and test the pump again for a different level. I need to go into the menu on the pump, select options and pressure levels. I'm going to go from 1 to 9, hit OK, and I need to reset the flow tracks to make sure that max pressure gets zeroed. I'm going to zero the pressure, real-time pressure, and we're set. So now I'm ready to start the pump again at 250 milliliters per hour, and at this level we've got a tolerance of the pump of 11.6 psi all the way to 20.3. So the pump should alarm somewhere between 11.6 and 20.3 psi. I'm going to hit start. I'm going to re-occlude the flow tracks. And now I can see the pressure climbing on the flow tracks display. It's up to 12 and a half, 15, 18. So the pressure trip point for the occlusion alarm on this pump for stage or level 9 was 18.14, and the max pressure on the flow tracks, which is passing for this pump. And we're done with occlusion testing. It's that quick. I didn't have to change any of my connections to the pump, and I got through my volume accuracy as well as my occlusion testing very rapidly. Now that we've done a volume accuracy test and an occlusion test on this pump, I want to talk a little bit about the air and line testing that often takes place when you're testing an IV pump. So most, if not all, IV pumps have air sensors designed into them to make sure that a large air pocket doesn't pass through the IV set to the patient because it could be hazardous. Therefore, a lot of PMs require you to do an air and line test of the IV pump to make sure that the sensors are detecting that air pocket. The idea with any tester, whether it's the flow tracks, a graduated cylinder, digital scale, is you don't want that air pocket to interfere with your next test for volume accuracy. In the case of flow tracks, there's a fast way to keep that air or bubbles from reaching the flow tracks and interfering with your next test by simply hooking up a syringe that's provided with the flow tracks and a 3-way stopcock. What you can do is after you've done your air and line test with the IV pump, you can start your pump and route those bubbles into the syringe rather than into the flow tracks by positioning the 3-way stopcock. So I'm going to start the pump. You can see some of these air bubbles traveling through the IV set from the air and line test. I've got the 3-way stopcock positioned so that those air bubbles don't go into the flow tracks but rather go into the syringe. And as soon as I see the last bubbles enter the syringe from the IV set, I can reposition the 3-way stopcock and start my next test. I don't have to remove this syringe for any of my other testing. I can keep it attached for my volume accuracy or my occlusion testing or whatever I need to. I just need to manage the position of the 3-way stopcock based on what test I'm running. So that goes real easy.